So if you look at that first segment, and this is a segment, remember from high school geometry or middle school geometry, however, wherever they brought this up, that this is not a line, because you don't see those arrows. You see end points, right? So that this is a segment. And in high school geometry, you learned about the symbol for segment is this notation right here. If I wanted this to be a line, they would use this notation with arrows, right? Okay, so that means segment. And I want to find the midpoint of the segment. You could probably guess at what the midpoint is. What's the midpoint? Where's the midpoint on this segment, do you think?
Between 2 and 3.
Tell me what it is, though.
2.
Remember, guys, okay, so you see how some of you are saying 2, some of you are saying 5. Okay, very good. So someone mentioned a point in a plane has to have an x and a y coordinate. Okay, so when I asked you what do you think the midpoint is, I really want you to tell me the x and the y coordinate. So you said it was what now? 2, 5. So you think it's here?
Yes, sir.
So that's the point. Remember, midpoint, that's the point in the middle of that line segment, of that segment, right? And sometimes they'll call a line segment. Although it's not a line, it's a segment. So if I count the distances, 1, 2, 3, 4, 5, 6, that's 6. The endpoint here is 6 units to the right, and this should be 6 to the left as well, right?
Right.
Okay, so I agree that is the midpoint. Let's talk about this in a different way, though. What are the coordinates of this point right here, the coordinates of A? What are the coordinates?
It's negative 4 and 5.
Negative 4, 5, so I'm putting negative 4, 5 here. And what are the coordinates of B?
8, 5.
8, 5? Okay. And we said the midpoint was what? 2, 5? Okay. So let's look at the x-coordinate of the midpoint. The x-coordinate of the midpoint is 2. How can I use the x-coordinates of the endpoints to get a 2 here? Subtract? What do you mean?
Is it subtracting all of your x-coordinates?
Well, 8 subtract the negative 4 is 10. You said subtract, so I am subtracting. 8 subtract the negative 4 is 10. Okay, someone said add. All right, let's see what we get when you add. What's 8 plus the negative 4? 4. But I wanted 2.
So you can do your you can do the 2
8.
All right, someone said divide. Mid means middle, right?
So you can do 8
So divide by
2
2.
minus 2.
So you add the x coordinates together and divide by 2. So to get the x coordinate, you would say negative 4 plus 8 divided by 2, right? And what's negative 4 plus 8? 4. And what's 4 divided by 2? 2. What about the y coordinate? Couldn't I do the same thing?
It's already there.
Oh, but couldn't I do the same thing was the question.
Yeah.
Yes. Add the y's together, 5 plus 5, and then do what? Divide by 2. So what's 5 plus 5? 10, and 10 divided by 2 is 5. Okay? So given a horizontal line segment, it's pretty easy to see what the midpoint is. All right, but now you know that you can add the x coordinates together, divide by 2, and add the y coordinates together, divide by 2. So if I look at this one here, at this one, what do you think is the midpoint of that segment?
2, 5.
2, 5? Y'all agree with that?
Yes.
2, 5? So if I look at the endpoints, what are the endpoints of A? Or what are the coordinates of A, I should say? Negative 3, 2, is that right?
Yes, sir.
What are the coordinates of B?
7.
7, 8? So let's use that same idea. What happens if I were to add the x coordinates and divide by 2? Let's see. That's negative 3 plus 7 divided by 2. And what's negative 3 plus 7?
4.
And what's 4 divided by 2? 2. Because we said that was 2, 5, right?
Yes, sir.
Over here, what's 2 plus 8? And 10 divided by 2 is
5.
5. So I could do the same thing, whether the line segment is slanted or whether it's horizontal. Okay? Now, I'm going to probably come back to this diagram in a little while, but let's go to the next one. Okay, the next one. All right, so the next diagram looks like this, and I should have used this one. Okay, that's this one here, right? All right, I'm going to come back to the previous one probably. Okay, so here you don't see any coordinates at all. It's kind of like a naked coordinate plane. But I'm going to call the coordinates of this point right here, I'm going to call this x1, comma, x1, y1. x1, comma, y1. So x sub 1, comma, y sub 1. So that's going to be my first point. So x sub 1, comma, y sub 1 will be my first point. When we talk about circles, you can see that same idea again, the notation. And over here, let's call this the second point. So I'm going to call it x what? 2, comma, y2. And somewhere on that segment is a middle point. So let's say it's here, right here. I don't know. Let's just say it's right here. Let's say that's your midpoint right here. And I want to find that midpoint. Now I can use the generalization we did earlier. If we go back to the previous two, how did I find the x coordinate of the midpoint? What did I do?
X1 plus X2.
I added the x coordinates together, right? So basically I said, well, that's going to be x1 plus x2 divided by what? 2. And then what about the y's? y1 plus y2 divided by 2. And that happens to be the midpoint formula. So if you're given the endpoints of a segment, so the endpoints of a segment are x1, y1, and x2, comma, y2, then the midpoint is, and what's the formula? How do you find the midpoint? You add the x's together and divide by 2, and then you add the y's together and divide by 2. All right, so that's the formula for midpoint. All right, let's talk about distance. So we now know the formula for midpoint. That's this right here. Let's look at distance. All right, let's do the first one. So I have this segment AB, and what is the length of that segment? What's the length?
11.
11. So I guess you just counted the units. So if I start here, then that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Y'all agree?
Yeah.
So the length of this segment is 11 units, whatever the units are. I could have also looked at coordinates to determine that. So if I look at the coordinates of A, what are the coordinates of A? -5, 6, is that correct? And what are the coordinates of B? 6, comma 6? All right, now remember this segment is horizontal, right?
Yeah.
That segment's horizontal. So given a horizontal segment in a plane, then you can count the number of units just by going across. Or you can do it this way. Remember, if I go across, this segment is parallel to which axis? The x-axis. So let's look at the x-coordinates. Is there any way I can get 11 from the x coordinates?
Subtract.
Subtract. Subtract. So I can say 6, look at this, 6 subtract what? Negative 5, which is 6 plus 5, which is 11. Okay? Now, I got to say this, though. Or you could have said negative 5 subtract 6, which is negative 11, but whenever talking about distance, when you talk about your height, it's always what kind of number? Positive. So I need an absolute value here. So the absolute value of negative 11 is what? 11. Okay? So we subtracted the x coordinates. So if I look at the one below that one, this one here, that's a vertical segment, we could count the number of units because it's in a plane that's easily countable. How many units is the length of this? 11? So 11 units again, right? All right, let's look at the coordinates and see if we can talk about that. What are the coordinates of A? 5, 7? What are the coordinates of B? 5, negative 4? And that segment is parallel to which axis? The y-axis, right? So I'm going to use which coordinates do you think? The y-coordinates. And will I add them or subtract them? Subtract. So notice we found the midpoint we added, and when finding distances, we're going to do what? Subtract. Although keep in mind that distance must always be what kind of number? Positive. So if I start with 7, I can say 7 subtract a what? Negative 4, which really is 7 plus 4, which is what? 11. So that's positive. I'm good with that. If I go the other way, I would get negative 4 subtract 7, which is what number? Negative 11. All right, but remember, distance can be negative, so I got to take the absolute value. So I'm going to go back over here and put this in absolute value bars, this in absolute value bars, and therefore my answer is what? 11. Okay? All right, now let's look at the next one. Okay, now let's look at this. I have this slanted one right here. So far, we don't know a generalization so far like we did with the midpoint. In the third diagram from the midpoint, we're able to generalize. We still can't do that yet. All right. I want to find the length of this segment. Subtracting the x coordinates, subtracting the y coordinates, and doing and saying, like we did a while ago, that's not going to be helpful. Because when I subtracted just the x coordinates here, that was dealing with a horizontal segment, right? When I just subtracted the y coordinates here, that was dealing with a vertical segment. Here, this is slanted. But I still want to find the length of this segment. Do you remember something from maybe a previous course that you maybe remember about? Okay, so you think of that in terms of slope, rise over run. A squared plus b squared equals c squared, someone said. What is that? Pythagorean theorem. Yep, that's the one you're going to use here. So remember when using Pythagorean theorem, you dealt with what kind of triangle? A right triangle, right? You dealt with a right triangle. So look what I'm going to do here. If I want to find the length of this segment, I can draw a right triangle. So draw a right triangle, just like this. Just like that. So I've drawn a right triangle. Remember this somewhere right here means a right angle. Okay? And it didn't matter which way you drew it. You could have drawn it like this, right? It would not have mattered. So in other words, someone else someone else could have drawn it the other way, like this, it would not matter. You just got to make sure that it looks like this. You're joining the endpoints. Okay, now remember Pythagorean's theorem. Pythagorean's theorem said that's an S. Said that in a right triangle, it doesn't look like a right angle, but that is. Remember, these two sides are here that I'm pointing to, those are called your, do you remember the words? Legs. Those are called legs. And the side opposite the right angle, remember what that's called? People, it wasn't too long ago. Hypotenuse. And I may have spelled this incorrectly, but hypotenuse. A lot of things you forgot when you were from being 1 year old. All right, and we denoted this though. Remember, we denoted the legs as A and B, and we denoted the hypotenuse as C. And Pythagorean's theorem said that that if I square the legs and add them together, that's going to equal the hypotenuse squared. So A squared plus B squared equals C squared. And that's what Pythagorean's theorem said. Okay? So going back to this problem that we're looking at right here, let's find the length of the legs. Once I find the length of the legs, then I can easily find the length of the segment that I'm interested in, because that segment is what part of this right triangle that I've drawn. Segment AB is what part of this hypotenuse. All right, so let's find the length of this segment right here. How many units is that? 7? Okay, I'm writing what you told me. So make sure you verify. What's the length of this one?
11.
It can be 7.
11.
Oh, 11. Okay, thank you. 11. And remember, so I'm glad no one said negative, right? Because the length has to be what? Positive. Okay. All right. So, and we don't know what this is, and we'll call that C, right? So I'm going to say 11 squared plus 7 squared equals C squared, right? Okay, on your calculator, what's 11 squared? 121. What's 7 squared? And that's going to equal C squared. What's 121 plus 49? 170 equals C squared. And then how to get C by itself? Take the square root of both sides. Okay, now be careful. You may say, what about plus and minus? No, you can't do plus and minus here. Because if you do plus and minus, you're saying that C can be negative. Can C be negative?
Nope.
No, because that represents length, represents distance. All right, so don't confuse that with equations you had earlier. Those were solving equations. Now, obviously, you're still solving an equation here, but it's a different context. Here you're talking about in terms of distance. So C would be the square root of 170. So let's just put that in your calculator. I don't want you to simplify this. Just put it in your calculator and tell me about what it's equal to. So square root of 170, make sure you know how to use a calculator. Square root of 170 is about 13.04. So it's about 13.04 units. So that's C. So notice though, we found so the length of segment AB is equal to the square root of what? 170? Which is approximately equal to what? 13.04. Now notice that we did this by using Pythagorean's theorem, but that's not the most efficient way of doing that, because you're not always going to have a grid in front of you, and you won't. So we have to come up with a formula for finding the length of a segment that's slanted. And there is one. But it does involve Pythagorean theorem, that formula. All right, so let's look at this then. So let's go to the next diagram. And so that's the one that says determine the formula for finding the length of segment AB. Okay, this one here. All right, now you have to listen very carefully to the discussion, because if you think about LSU's game today for a split second, you're going to miss out and you're lost. If you forget about how you're going to get home today, which path you're going to take, you're going to get lost. So listen to my words. Don't listen to your neighbor. Don't listen to music on an iPhone. Listen to my words. All right, I'm going to call this second point, first point, just like we did before. Remember we did the midpoint? So I'm going to call this what coordinates? X1, Y1. And this will be X2, Y2, right? Okay. All right, I'm going to draw a right triangle just like I did before. I'm going to draw a right triangle just like this. So we're coming up with a formula for finding the distance. All right, now listen carefully to this. See this point right here? Right here? What do you think, using x1, y1, x2, y2, what do you think are the coordinates of this point right here? Huh? It's got to be one of these. No, it's got to be one of these. X1, Y1, X2, Y2. Tell me what goes here. Okay, he says X2, Y1. I'm going to write down what he says. I'm just going to put it right here because it could be wrong. He says that this X coordinate is X2. And he says that this Y coordinate is Y1. All right, let's talk about it. See this right here? Let's go back. Let's go back over here. What were the coordinates of this point right here? -3, comma 7, right? Well, you agree that any point on this line, the x-coordinate is -3?
Yes.
Okay. So do y'all agree that if this is x2, then any point on this segment, the x-coordinate has to be x2?
Yes.
Okay, good. So it is x2. Let's talk about the y-coordinate. What about the y-coordinates that are on this segment right here? What are they? They're y1. Because look, what are the coordinates of b right here? 4 what? -4?
Mm-hmm.
So in fact, this right here, any point here has to have what y coordinate? -4. So if this is x1, y1, then any y coordinate here has to be what? y1. So yes, you are correct. It is x2, y1. All right. Now, remember a while ago when we talked about finding these distances of horizontal and vertical segments. To find the length of a horizontal segment, I subtracted which coordinates? I subtracted which coordinates? X. Because it's parallel to the x-axis. I always subtract the y's because what's 6 minus 0? What's 6 minus 6? 0. When looking at vertical distance, I subtract the y's. X not going to help because what's 5 minus 5? 0. Okay. So when you look at this right here, this horizontal length right here, which coordinates are you going to subtract? Are you going to say x2 minus x2? No. That's 0. You're going to subtract what?
X1, Y1.
X1 minus Y2, Y1 minus Y2, or you can say Y2 minus Y1. But remember, that distance must be what? Positive. There were situations earlier where we got negative and we had to use what idea? Absolute value. So I'm going to do this. I'm going to write this as absolute value of Y2 minus Y1. So that's the length of that, right? What is this horizontal length right here? What now? X2 minus what? X1, but absolute value. X2 minus X1. Okay? And I'm trying to find this distance right here. This distance, I'm going to call this D. I'm trying to find D. Okay? All right, so let's use Pythagorean theorem. Remember, Pythagorean theorem says I square each of those legs, add them together, and that's going to equal the square of the hypotenuse. Okay, so listen carefully. So I'm going to square this leg right here. Notice right now it's in absolute value bars, right? But when I square it, doesn't it automatically make it positive?
Yeah.
So I'm going to just put this in parentheses, x2 minus x1 squared. Plus, when I square this side, isn't it automatically going to be positive? So I'm going to just say y2 minus y1 squared. And that's going to equal this what? D what? D squared. Pythagorean theorem. The legs squared add together equals the hypotenuse squared. And then, just like we did a while ago when we did this one, how did I get C by itself? Square root. So to get D by itself, I'm going to take the square root. So I'm going to go ahead and rewrite this over. And then take the square root. Do I do that plus or minus? No, because you're not, in terms of this context, you're looking at distances. And so the square and the square root undo each other. Oops. Oops, I did not mean to do that. This square and the square root undo each other. So D equals the square root of what? In parentheses, x2 minus x1 squared plus y2 minus y1 squared. And that is your distance formula. That's your distance formula. So in finding the distance between any 2 points in a plane, there's your formula. And notice, if you remember Pythagorean theorem, it's not too difficult to not remember. I will give you this formula, you just need to know how to use it. So the distance formula says you subtract the x coordinates from each other and do what to it? Square it. Subtract the y coordinates from each other and do what to it? Square it. Hence Pythagorean theorem. What do you do to those two things having parentheses? Square it. Add them up and then do what? Square root. All right? So, if x1, y1, and x2, y2 are endpoints of a segment, then the length of the segment, is given by this, the square root of x2 minus x1 squared, that's an x, plus y2 minus y1 squared. Okay? That's your formula. So 2 formulas you learned. The midpoint formula and the what? Distance formula. And we're going to do a few problems with those when we come back, and then we're going to get into circles. Circles involves, some of the circles we're going to do is going to involve using this formula. All right, so we're going to take 10 minutes.